Hi, hello, welcome and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video we're going to see about what is an image. So what is a container image? And in the recent days, in the recent past days, we were seeing about the the Kubernetes training. We were seeing from the beginner to advanced, and we discussed about what is a pod. We discussed how to create and how to connect the lens with Kubernetes so that we can monitor the pods. And then we have also watched a video on how to create your first cron job. We saw how to, like what is a pod, a deep dive into pod, and we also saw about how to create multiple containers inside a single pod. So today, in this video, we're going to see what is a container image and why do we need a container image and what are the components of a container image and how an image is created. So we're going to see every single thing about an image and I'll explain you why an image is needed so that you understand how does it work and why do we really need an image and why do we need to have an understanding about what is an image. So before we move on to this video, this is me, Asan Shanmugam. I welcome you all to our Let's YouTube channel. Please don't forget to subscribe to our channel if you haven't subscribed it yet, and don't forget to join my channel for more interesting and informative content like this. And please give a thumbs up if you like this video and share the video with your friends who are learning Kubernetes or who are interested to learn Kubernetes and become an SRE, a DevOps engineer or a platform engineer, right? So there are like lots of opportunities for those who are learning the Kubernetes. And coming back to the topic today, so here in the lens, so we have got the Nginx pods, right? So for creating these pods, I have used an image, right? And I have used the Nginx image. If you remember, we have used an Nginx image to create these pods, right? So, so here, this is the code which we used to create the container, right? The Nginx service, the Nginx deployment. Yep. So we have pulled the image, the container image, which is the Nginx image. So here you can see the Nginx image, which is version 1.14.2. So what exactly is a container image? So a container image is a very lightweight. So you can see it's very lightweight, and the moment we pulled it, it automatically come has been downloaded to a machine and it started to install. So it's very lightweight. It's a standalone. It does not need any other thing, any other components to run on. So here, if you see, we just pull the image and it automatically did what it was supposed to do, right? So it's standalone, and then it's an executable package. So when we pulled it, automatically it did whatever it executed the package, whatever it did want it to do, it did it, which includes everything. It just needed to run the piece of software, right? So just to give a quick look, so a container image is lightweight, standalone, and it's a executable package, right? Which includes everything. You just needed to run a piece of software, right? So what does this container image contains? What does this container image consist of? So it consists of a code, which is the application itself, and it has a runtime. So the environment in which the code runs, it can be a Node.js, it can be a Python or whatever it is. So the environment in which the code actually runs, and then the libraries are dependencies. So all the software the code depends on, like frameworks, the packages, and the binary. So all the software, whichever like any dependencies or any libraries which it depends on, and then the system tools. So basic utilities which are needed for the application to function. So it involves or it includes the system tools as well, and then the configuration files, so the environment variables, the config settings and metadata. So it includes all these five pieces. Like first thing is the code, the application itself, and then the runtime, so the environment in which the code runs, the libraries and the dependencies where all the software the code depends on, the system tools where it includes the basic utilities which are needed for the application to function, and then the configuration files. So let me add this point. So an image consists of the code, the runtime, libraries, and dependencies. So just imagine like if you're running Java code, it has a runtime, right? So it's something similar to it, and it has a library. So when you're like considering a code like Java, it's a code, it has a runtime, it includes libraries, it includes dependencies, it also has system tools with it, and then the configuration file. So just imagine if you have like a Java file, and you are packaging it, and that becomes an image. Okay, so a container image which serves as the blueprint for creating the container. So when I'm using this particular image, it is creating the, or it serves as the blueprint for creating the container. So I'm creating a container using this image inside a pod, where which are like isolated environments which are running on a host machine, which is my machine now in this scenario. So an image is a static and it's a read only, meaning it does not change once created. So once this particular image is created, so initially it was created by someone, right? So once it was created, I mean, it's static and it's read only, which is it does not change once it is created, so it cannot be changed. Okay, and the containers, in contrast, are the running instances of these images. So containers, once I run this file, it creates a container for me, and those containers are the running instances of these images. Right. So I hope you understand what I'm trying to say. So images is different and containers are different. The containers comes from the images, and this images are the blueprint for the containers. Okay, so why do we need a container images? So that's the next question, right? So okay, we are seeing these images here. So why do we need a container images? So consistency across environments is very important, right? So you are having multiple environments like dev, sit, the UAT, and production, right? So these images, okay, they ensure that an application behaves the same way regardless of the environment, whether you're running the image on your local machine, a test server, or in a production. So the underlying environment is always the same. Because of this, it solves the very classic problem. So a developer will say that the application works fine in my machine. Okay, so what the next comment will be like, okay, then let's send your machine to the client, right? So this is what is happening here. So when the developer says that it's working in my machine, okay, let's package it, let's send it to the other environments. It works there, right? So that's what is actually needed. So it maintains the consistency across the environments. And next, the portability. So the container images are platform agnostic. So you can move an image from a local development environment to a cloud platform, and it will work the same way. So you don't need to worry about whether the OS or dependencies are compatible, because they are bundled within the image. That's the portability part. And then when it comes to efficiency and speed, container images are lightweight and start almost instantly compared to traditional virtual machines, which need an entire operating system to boot. So when it comes to the efficiency, container images are lightweight. Because of that, they are more quicker, I would say, more faster compared to the traditional virtual machines. Okay, and then when it comes to the isolation, each container run in its own isolated environment, which means that the libraries, dependencies, and configurations of one container do not interfere with those of another container. Okay, so I have like multiple containers here. If you see in my lens, I have like multiple containers, right? So what happens is, even though I have all these containers in my same machine, they were all isolated, which means they have their own libraries, they have their own dependencies and configurations of one container, but they do not interfere with those of another containers. And because of this, it provides security and avoids dependency conflicts. And also, container images can be versioned. So here, if you see, I have these images, right? The container images, so they can be versioned, right? So you can easily track changes in the application code, the environment, and its dependencies. So this is very critical in modern DevOps practices like continuous integration and continuous deployment. We all know, so that's why we do this versioning part. And then scalability. So in system like Kubernetes, container images allow for scaling applications. The same image can be replicated across multiple containers, which allows for easy horizontal scaling. So like we do, I have created multiple containers using this pod. So I have like scaled up. Like initially I had one pod, then I have replicated to three different pods. So that's the way you can scale up. So why do we need container images? So let me go back here, and the reason for having the container images are consistency, then portability, efficiency, isolation. That's the main part for the security purpose, and then the versioning to keep track of what changes was released at which version, and then the scalability. That's the main importance of having this containers. So now I have this Nginx, right? Nginx 1.14.2, right? So we'll break down this particular image uh, to its base layer and application layer. So it has a base layer of Nginx 1.14.2, which is likely a minimal Linux distribution like Debian or Alpine. So it depends on the variant of the image. So in default, Nginx image, the base layer is Debian. So this layer, the Debian layer, provides a minimal operating system which with just enough to support Nginx, including libraries, the utilities like whatever I'm mentioning here. So Debian along with the libraries, utilities, and the configuration. So for example, like a Debian image provides system libraries like G library, shared objects, and basic utilities that Nginx depends on. And then apart from the base layer, so it has the first thing which is the base layer, and then it has the application layer, right? So the application layer contains the Nginx web server binaries and configurations because it basically is a part of web server. So it includes configurations, which is like a default HTML file for the welcome page, and any environment variables like network configurations, custom settings for running Nginx. So these layers are created when instructions like copy or run are executed in the images Docker file. So let's um, pull the Nginx file image, and I mean, let's do one thing. So what I'm going to do is Docker history Nginx colon. Let me just copy this 1.14.2. Let me copy this here. Yep. So let's see the history of it. Okay. No such image. Okay. Let me pull this image first. So Docker pull uh, Nginx. Yep. So I have pulled the image and I'm downloading it. Meanwhile, let me just check here. Okay. Yeah, I'm downloading it. So once it is downloaded, now what I'm going to do is I'm going to see the history of it. So this will show us the base layer and the application layer. So then Nginx colon. Yeah. So here, if you see, let me just maximize it. Yep. So here, this gives a breakdown of the image layer, their creation commands and sizes. So here's an example of what it output is. So the layer with uh, the file, I would say, yep, this one, the file, the image. So previously it was started this way. So previously it started from here, the add file, right? So this is the layer with add file. So this is the first step, the base layer. So this is usually the base OS layer. It's just Debian or Alpine, and it has around a size of like 55.3 MB. So this base layer contains the core operating system that the Nginx relies on. So this is the base layer, the add file. So this is the file, or this is usually the base layer, the first step that we are doing for the image, right? And next, moving to the application layer, the Nginx installation, the layer that includes the set. Where is that set minus X? So when it comes to the application layer, we have the apt minus get update and apt get install. So this is the layer which installs the Nginx and any required dependencies, which has actually added 53.8 MB to the image, and this is where the Nginx is set up and is the most critical application specific layer. So after the base layer, this is the next step for the application layer. So again, you can see a lot of data has been added, and then in the layer 4, the uh, in sf dev std out. So this is the next one, next layer. So this layer adds logging configuration for Nginx, which is directing logs to the std out. So here you can see the logs to the std out, and this is part of the Nginx setup for the Docker environment. And then finally, for the application layer, we have the add file. So this we already discussed. So this likely contains the Nginx specific binaries or configuration files, adding another 55.3 MB. So these layers together form the application layer, as they contain the actual Nginx web server and its configuration. So without these, the image would not run the application correctly. So yeah, so far we saw about an image. What is an image? What's a container image? What does it contain? What exactly is it? And we also see the two important layers of an image. And in our next video, we'll see how to create an image and how to uh, create a pod and how to use a container out of it. So like I told you, the images are the blueprint of the containers, and the images are static, and they are not they won't be changed, right? Once it is created, they won't be changed, but the container is running on top of the images, right? So these are very simple, but just remember, and then again I'll tell you, like, keep on practicing it so that you will understand the Kubernetes very soon. It has a lot of learning curve, but still it's very easy to learn. So I wish you all the very best, and until I meet you in our next video, it's bye bye from Mugam and your favorite Little Star YouTube channel. Take care and bye bye.